everyone. Welcome to another episode of Cyber from the Frontlines. Today, we are going to focus on malware analysis and how to use Ghidra for that. And it's my great pleasure to welcome Abhijit Mohanta to this episode of Cyber from the Frontlines. Abhijit, as you can see, has written multiple books, one on malware analysis and detection engineering, as well as preventing ransomware. And he also uh, speaks a lot at Black Hat conferences as well. Welcome, Abhijit.
Thanks, Arun, for the introduction. So today I will be talking about malware reverse engineering with Ghidra. So let me give you a quick introduction about myself. I'm CTO and co-founder of Intelliroot, and I'm author of the books Malware Analysis and Detection Engineering and Preventing Ransomware. I have 17 plus years of experience in malware analysis and writing malware detections. I've worked in antiviruses, sandbox, and EDR development, and I've worked in research labs of McAfee, Semantic, and Juniper networks. I've spoken in conferences like AVAR, ZipCon, DMZCon, DSCI, AICT, and also I would be providing my training in Black Hat December this year. Apart from that, I'm a cybersecurity trainer as well. So today we'll talk about what is reverse engineering, why we are using Ghidra, and we'll explore some Ghidra basic features, and we'll understand how to find some interesting stuff using Ghidra. And just we'll talk about some quick overview of Ghidra script. So why Ghidra? So Ghidra is a free and open source reverse engineering tool developed by National Security Agency of United States. And the binaries were released at RSA conference in March 2019. The sources were published 1 month later in GitHub, and Ghidra is seen by many security researchers as a competitor of IDA. So some of the features which are present in Ghidra are present in IDA as well, but the same features are very much expensive in IDA. So that's that is the advantage of Ghidra over IDA. So it is a free compiler. It has nice features which are comparable with its expensive competitors. So before switching on to Ghidra, let's talk about what is reverse engineering, what we do in reverse engineering. And before understanding a bit about reverse engineering, let us understand about how codes are compiled, or what I call as forward engineering. So this is a simple program, C program, which most of you might understand. So it just does some of the stuff, like it prints a hello and it has some variables in it. So it's pretty much easy to understand. When you compile this program, basically what happens is some machine code is generated, and that machine code is embedded inside an executable file. So this executable file, in this case, I am showing a Windows executable file, which is a exe, or which follows P file format. Similarly, for Linux, if you want an executable file for Linux, you can ask the compiler to compile it into ELF format. Now, next, when it comes to reverse engineering, basically the machine code inside this executable is extracted and displayed by tools like disassembler like this, which is in the assembly format, which is in the assembly language. And after that, this assembly language can be decompiled into pseudocode. So you never get the exact code. You are never going to find the exact variables, but you'll get a pseudocode. And from there, you need to understand how was the original program written. So for an example, here I have mentioned that integer a equal to 3. So in the decompiled code or in the disassembler, you cannot make out the name of the variable a. And it might often be hard to determine directly by looking into the disassembly or the decompiler that something is an integer. And these are the things which a reverse engineer needs to do. He needs to figure out uh, what is the uh, what is the data type of a particular variable. So these kind of things are done by reverse engineer. So if you see this code is pretty much unreadable. And using disassembler, we get the assembly code, which is time taking to read. And when you compile the disassembly, then you are going to you would be able to read it much faster. So now, how do you reverse engineer with Ghidra? So basically, Ghidra takes up a file format. So in this case, I'm just showing P file format. So Ghidra has parser for the particular file formats in which it locates the machine code. And the parsers which parse the file format in Ghidra are known as the loaders. So Ghidra supports many loaders like P loader and ELF loader and many others. And after locating the machine code, Ghidra translates this code into disassembly. And this is done by the processor module in Ghidra. So Ghidra has specific processor module for a specific processor. Like there would be processors for ARM, x86, x64, and many others. And these processor modules are going to convert the machine code into disassembly. And further, with help of Ghidra decompiler, you can see the code you can see the pseudocode. Now, these are the things which we would prefer Ghidra for. Like it supports multiple file formats, like it supports ELF, it supports P executable. So Ghidra has loaders for all these different file formats. And it also supports multiple processor. So I have listed a few of these, and this includes x86, ARM. Similarly, decompiler is another feature, which is one of the best free decompilers out available there. So these features are not present in any other free tool. In case of IDA, these features are available only in the paid version. So let us talk about some basic setup about Ghidra and some basic settings. So for installing Ghidra, you first need to download GRE and JDK and install it. After that, what you can do is you can download Ghidra from this website and then unzip it. After you extract the zip, you will get a folder somewhat like this. And in order to start Ghidra on your Windows machine, you need to execute this ghidra run.bat, which starts a user interface, which looks like this. You'll see the Ghidra dragon here. So in order to analyze a executable in Ghidra, you first need to create a project for it. So you can go to the file menu and start a project. And after that, put the project name. And uh, here in this case, you can see here, I put the project name as malware. And after I create the project name like this, it looks like the user interface looks like this. And after that, what I need to do is I need to add files which I want to analyze in this project. So what you can do is you can again go to file menu and then import a file. Then you can browse to the directory where your malware file is there. And after that, click on that file and Ghidra would be loading that file. When you load it initially, it will ask for what file format you want to load this. So here it has already guessed that it is a P executable, and it has done some other guesswork as well, like Boolean, Delphi, and other things. And uh, here's a file name. Next is the project manager looks like this after you import a file in Ghidra. So in this case, you can see here there is the button for code browser. There is a button for debugger. So Ghidra also has a debugger, but it is not so good compared to other debuggers on Windows. So here is the project file, and under the project file, you have the files imported for a malware analysis. So in this case, I've imported the file name with this. So that's why you are seeing like this. So after you double click the imported file from the project manager, you will be getting a prompt somewhat like this. And here you can choose this option for Windows. So Windows x86 propagate external parameters. So this would be useful while you are analyzing Windows executables. So let us look into some other things in the user interface. So Ghidra has multiple windows like the symbol tree, disassembly window, and the function window. So uh, here is the Ghidra user interface, and you can see exactly what I have shown in the slides. So basically, this is the disassembly window, and here basically you can open multiple windows. So in this case, my function window is open, and here is the symbol tree on the left side. And after that, here is the console, and you can see here something related to function. So basically by default, sometimes strings are open. So basically if you want to open any other window, for an example, I can close the functions window, and after that go to the windows and open the functions again. So that time it will be prompted here. So you can also drag drop these these windows to other places as well as per your convenience. So you can alter this UI as per your convenience. So these are the windows which I opened by going to the uh, window menu, and after that choosing any of these uh, buttons. So let me switch back to my slides. So as I showed in the Ghidra Windows menu, you can select these options in the menu bar, and accordingly something will open up for you. So you can open the decompiler, you can open the console where output of your scripts and commands are there. Here defined strings are there where you can see strings in the binary. Here you can see the disassembly also, which is there by default. You can see the function, then function grabs you can see, the function call trees you can see, scripting manager you can see, and there is a symbols also. Later I'll be talking what is the difference between symbols and the strings. So in the top you'll see the Ghidra menu, and it has all the things whatever you can see in the windows. So basically all these are the options. Basically what you need to do is you need to hover over these options and see what they are prompting, and accordingly you can click those and get it. Like for an example, if I click this run button, it shows me the display script manager, and I click here and I can see the script manager here from where I can execute the Ghidra scripts. So next is some basic settings like changing the fonts. So if you see my user interface, my fonts are very much small, and often it would be very hard to read on a small screen. So what I can do is you can go to the edit option, tool options, and here this is the listing display. So this basically is the option to change the things in the disassembly listing. So here I can change the fonts. So in this case, let me change the fonts to 20 and apply. And immediately I'll see here the fonts are larger now. Similarly, I can change the things in decompiler as well. So if you see here, the decompiler fonts are very small. So again, I can go to the edit menu, and after that, go to the decompiler, display, and after that, when I go down and click here, I can change the display as well. Now you can see it is better to do it. So these are some basic settings you can do in Ghidra. Similarly, there is one more option you should always remember selecting while reading this feature. Basically, it is related to highlighting code. So this would be very helpful while reading the code. So basically, what happens in this case is, say suppose if you click on some string, it is going to highlight all the strings related to it. So whenever you are reading the code, this feature is very much helpful. So you can go to this options, then go to edit tool option, listing fields, cursor text highlight, and by default it is middle, and you need to change this to left. And now if you select a text like this, so in this case, I've selected ESP. Now you can see all the ESP are being highlighted. So this is useful while reading the code, whether it is in disassembler or whether it is in a decompiler. Now code analysis. So if you want to start code analysis, and if you want to start with the very first function or the entry point of the binary, you can select, you can start with the function window. So let me switch to Ghidra. So what I can do here is, let me click the functions window. And my function window is here. And here, if Ghidra shows the entry point like this, it has named the entry point somewhat like this. So if I search here, it takes me to the entry point. So if I click here, it takes me the entry point code. So here is some code which I'm looking at too. Next is, if you observe the code in Ghidra, Ghidra has basically it is going to name some variable functions by itself. So like this, in this case, it has named their entry. So if you switch to, if you check other things as well, so it has named the functions like this. Let me just drag this. So it has named the functions like this. So you can see here, it has named the local functions like func 4004E7, and it has named the parameters like param1, param2, param3, and the local variables like local 10, local 12, and local. So if I look into the decompiler as well, you can see here, Ghidra has named the variables, whatever it sees. So you can see here, it has named some variables like this. So this, it has also recognized data types in some cases, like this is the D word, and here is the variable name. It has automatically renamed to dvar1, and some other data types it could not recognize, so it has put like undefined. And you can see Ghidra has recognized the APIs as well. And you can see it is able to recognize loops. There's a do while loop here. There is a if else condition here. So basically, you can see how much Ghidra makes your reverse engineering task easy. So basically, Ghidra is going to show you parameters, what are the important, and while analyzing a function, you can look into the parameters, what are the important piece of code in the function. Like you can guess by looking into what are the APIs called, what are the strings used in that function. You can also check what functions call this particular function and what functions are called from this particular function. Then you can look into graph, and then you can look into the decompiler as well. So say suppose I'm looking into this particular function, I can look into this function, and if I go to the window and go to the function called trees, it gives you somewhat like this. It shows you some windows like this. So my window is down below. In case if it doesn't appears below, then you can just uh, put it below or wherever you wish. So you can see here the incoming calls. That means which functions are calling this, how they're calling. So you can, if you expand this, you are going to see that it is coming from the entry point till this. And what are the functions that are being called from this particular function? So it tells that here two APIs are there. That is get logical drive and get drive type W. Also, you can look into the decompiler as I mentioned earlier. So whichever functions you are in, so if you go to the decompiler, it is going to show you the decompiled version of that disassembly. So if I click here, it is going to show you the de decompiled version of the code you selected. Next thing is you can look into the graphs as well. So if you see here, click on this, then it is going to show you the graph of this as well. So here is the button for the graph. And you can see here the graph. So you can minimize the graph. You can scroll up and down. Okay, so you can use Alt and Control button for scrolling the graph and increasing the size and other things. So you can see here, I use Control. I can use the scroll button to minimize the graph, and I can press Control and scroll up and down to see the code in it. So this is the practice you should do while reading the code. Next is two things we are going to learn about is symbols and strings. So basically, if you see here, you go to window and go to the defined strings, you are going to see the strings in the binaries. So here are the strings which are seen in the binaries, and this is not going to change even if you open this binary in IDA Pro or any other analysis tool. So these strings are fixed for this binary. So this is never going to change. Now let us go and see the symbols. So I can go to the window and select symbol references. So if I go here, I can see here in the symbol references window, I can see here on left hand side, there are the symbols. So what are these symbols? So symbols are something which is generated by Ghidra. So this, if you open the binary in other tools, so these things might not be present. So Ghidra has ability to name the APIs. Ghidra is going to name the function in its own naming convention like func. So IDA might use their own naming convention. Similarly, Ghidra can name the variable parameters somewhat like this param and all these things. So basically, symbols are the representations of some of the data like your function names, your variables, global variables uh, in some particular tool like Ghidra. So this thing will change for different tool. And basically, you can use symbols and the strings for finding out interesting stuff. So this is what I explained. So symbols, strings are the ones which are present in binary by default. Strings are same if you analyze the binary in any other tool as well. So symbols are used to represent location, function, variables, etc. in binaries, which are created by the analysis tool. Like in this case, we are seeing in Ghidra. So symbols are specific to the analysis tool. Like Ghidra names the function in the following manner, and you can see these things in Ghidra only. If you open the binary in any other tool, you are not going to see the thing. So if you edit the string, it is going to change in the binary. But if you edit the symbol or rename the symbol, it is not going to matter. So next, coming to identify important functionalities using the strings and X references. So for this, you should have understanding of uh, what are the interesting strings you see in a binary, and what are the interesting API calls you see in a binary. So you should be very well of you should be aware of malware analysis before before you should be able to identify interesting functionalities. So for an example, the binary which I am showing is Spora binary. So this is Spora is a ransomware. So all the ransomware has some functionality to delete the backups. So for deleting the backups, they use Windows binaries like VSS admin or BCD edit. So what I can do is I can go to the strings here and search for VSS admin. So if you see here, if you see the string, it shows like process, call, create, and you can see the VSS admin here. So now if I click on the string, it shows me the string in the disassembler. And if you go for the right, you can see that the string is being referenced at this particular location. It is, the string is being referred in this particular function at this particular location. So if you simply double click this one, it is going to take you to this particular location. So now, if you want to understand what this function is, you can just go to the decompiler. So when I go to the decompiler, it shows me the decompiled code or the pseudo code. So basically, after looking into this API, you can guess that it is executing this particular command, which is this was the command. So this is the VSS admin command. You are seeing a representation of it. So basically, you can label this function for convenience. Like I can label it like right click on this and rename function or press L. So you can consider this as backup deletion. So you can see here, I renamed this function to something else. And now if you go to the symbol tree, so let me go to the window and go to symbol references. And here, if I search for backup deletion, so you can see here the function which I named is here. So you can see here, it's not a string by default, but I named this particular function like this. So these are the symbols. Now next. So Ghidra is able to identify the APIs, and you can see the list of APIs in the symbol references as well. So basically, if you look into ransomware, they would be calling APIs like create file, set file pointer. So let me search for a set file pointer. So you can see here a set file pointer is there. Now, if I click on this, it shows me that the set file pointer is being referred from multiple locations. So basically, you need to analyze all these function and see which is the function responsible for encrypting the file. So you need to do a deeper analysis of this. So if you see here, this particular function, so there are multiple functions which are using set file pointer. And if I click this function, it takes me to this particular function. And if I inspect the decompiled version of this function, this calls something like, it calls some APIs like crypt encrypt, set file pointer, and write file. Okay, so basically, if you see these functions together, there is a high probability that this particular function is responsible for encrypting the files. So this is how you do analysis in Ghidra. So can RE tasks be automated with Ghidra? Yes, they can be. So you can do scripting in Ghidra as well. So what I've done is I've written one script, and you can download the script from my GitHub location. You can scan this for the link to the script, and you can put it in Ghidra scripting folder. And now if I run this script, so I can go to scripting manager. I have placed the script in the proper directory, and my script name is, oh, just a minute. Okay, so there is one script, malware function reconner v2, reconner v2.py. So this is the location for automating Ghidra in this automatic Ghidra using headless mode. So in this directory only you are going to find, if you go to this directory, you are going to see some additional script, and one of the script is this one, malware function underscore recorner underscore v2. So if I run this script, it is going to identify the functions, and it is going to tell me which functions is pointing to which string and which APIs it is calling. So it takes a little while. Yeah, so it has executed, and now this one lists me some of the function. So if I go to VSS, search for VSS admin, so VSS admin is called from this particular function, which I named as backup deletion, and this is the function start. You can go here and look into it. And similarly, if you search for crypt and crypt API, it is being used in this particular function. So most likely this function is the one that is responsible for encrypting the files, because if you see the list of the APIs being called from this particular function, it is basically, it checks, it gets the attribute of the file, it opens a file, then it sets a file pointer, then reads the file, and after that it generates some keys as well. Okay, it then it encrypts the file using crypt encrypt API. So you need to have understanding of all these APIs and the strings before uh, going deeper into this particular binary. So if you are interested in reverse engineering and learning more about tools like Ghidra, IDA Pro, you can come to my lives training, in-person training in Black Hat, Middle East, and Africa. And if you want to have an on-demand version of my training, you can uh, contact me, and you can see the syllabus in academy.intelliroot.com. That's it.
Thank you so much, Abhijit. This was very, very insightful, especially the scripting that you showed, how to automate some of the analysis part that we can do is really, really good. I'm going to check out those scripts on your GitHub page, just so because I like to do malware analysis as well. So, but this was very, very uh, useful. I just had a couple of things. So, if you could explain the difference between IDA Pro and Ghidra in the sense what are the key features and what are the pros and cons of
Mhm.
both of them?
Yeah, I can give you a quick overview. So both the tools have plus and pros and cons. So IDA has support for everything because it's a very, it's very old tool and very popular, and it has a lot of support for all different kind of binaries. It has a very nice decompiler. It supports some other stuff like, it supports different architectures as well. Ghidra also does the same thing. But IDA has many other features, like its debugger is very nice, and the debugger feature in Ghidra is still evolving. It's not so friendly as of now. IDA can do other stuff like kernel debugging. Its debugger is very good compared to uh, Ghidra. Sorry, IDA's debugger is very much good compared to IDA. And but the one thing is, like, IDA is the features which IDA provides, like decompiler and many other things, are pretty much expensive.
Mm.
So that is the demerit of IDA. But IDA is, yeah, you can buy it. It's very much useful tool.
And are you able to automate in IDA Pro as well? Like you can create scripts.
We can do some stuff in IDA, but I've explored more things in Ghidra actually. Since after Ghidra was launched, I used a lot of Ghidra. So earlier I was using IDA a lot, but yeah, Ghidra is some things like I can automate analysis of multiple files at the same instance, like using Ghidra in headless mode. So I have given a script as well, which you can download from
Nice.
this location. Okay.
Mhm.
And yeah, and you can automate binary analysis a lot. Like you can uh, put hundreds of files for analysis and go to sleep, and the next day you can see the analysis. Okay.
That's really nice, especially with malware analysis, assembly level language. It helps a lot if you can
Yeah.
scripts and automate part of it.
Yes.
Uh, so I wanted to also, I was curious about the books you wrote. Malware analysis and detection engineering was one. Uh, tell us something about that. What is it all about? Uh, is it based on IDA, or is it? Do you also talk about Ghidra there, or?
I have not mentioned Ghidra in that malware analysis and detection engineering. So, but it has reference to IDA, and it has reference to OLI debugger, x64 debugger. Ghidra was relatively new when I wrote this tool in 2019, and relatively it was lesser used during that time. It's not 19, but I think yes, it was released in uh, 2020, as far as I remember. Yeah, that time I was writing the books, and Ghidra was just picking up that time.
Nice.
Uh, Yeah, so it has, it's the book is good for beginners as well, for intermediate as well, and there are some stuff for advanced as well. So that this was the only book at that time which was focused on detection engineering. So
Mm,
the special things in this book is like it is very beginner friendly. Like you can understand the basics by reading this book,
mm,
and detection engineering is the special area where I talk about the internals of antiviruses, how it works, and how sandbox work, and how IDS IPS works. So basically, those of you guys who ever want to work in malware research or want to develop antivirus or EDR engines, so that book, this book would be the useful ones.
nice. That's good to know. And you also wrote another book, Preventing Ransomware. Can you briefly talk about that as well?
Yeah, so this I wrote, I think, in 2016 or 17. And ransomware is the basic focus in that. So I've talked about how ransomware is analyzed, what are the different kinds of ransomware that were seen during that time. Like I think I wrote about WannaCry and some of the other popular ransomware. Even I've talked about the history of ransomware, how the initial ransomware looked like ransomware started with some things like jokes, and the initial were the screen locker ransomware. So even I've talked about the historical ransomware as well.
Very nice. This is really good, and I really enjoyed um, listening to
Mhm.
this show on Ghidra. It was really good. And I haven't checked. I usually use IDA Pro, but I have not checked out Ghidra. So probably an opportunity for me as well to take a look and see what features could be used.
Mhm. Yes, thank you. So I just wanted to quickly talk about my on-demand training, if you
Sure.
don't mind.
Yeah.
Uh, Yeah, so this is my on-demand training. So it is malware reverse engineering beginner to advanced. So you can, this is a on-demand, so you can, enroll for the training and then go to the videos by yourself. And I would be available for doubt clearance, and monthly there would be doubt clearance session. And this is a training that is even meant for people who want to start into the anti-malware industry. So even though the main focus is on reverse engineering, but there are basics of malware analysis. There are I have explained about detection engineering. I have taught about learning writing some basic tools, which are you can consider those as part of EDRs, like memory scanning and like ETW, all these technologies. And apart from, there is a quick section on writing malwares as well. That is a very short section. So these are some additional things which I have provided in my training. So whoever wants to make get into malware analysis, get into reverse engineering, blue teaming, red teaming. So this particular course is designed to cater every level of malware analyst.
Very nice. I'll check it out as well.
Yeah.
Great. Thank you so much, Abhijit, for your time. It was really, really insightful. Thank you.